Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video we will learn how to debug the code in STM32 IDE. So how to debug the code, that part we will understand in this video, but before starting the video, if you are new here to my channel, kindly subscribe my YouTube channel and click on bell icon and share this videos to your friends and colleagues. Let us start the video how to debug a code in STM32 IDE. So guys, before starting the video, the one more important thing I want to explain here. For demonstration purpose, I am considering here ADC interface. So I have already explained what is ADC, how ADC works, and how ADC will produce output in the previous video. Please watch that video. I will update the link in the description. So now our main focus is to debug the different registers in the code view. So how to debug or how to identify what is going to happen in the register level, that part so you can see this is my cube IDE, and here, so whatever I have explained in the previous steps, you can see this is one parameter I'm going to explain how. One is AHB, APB2, then ADC common, then sequence register, then control register, then the status register, then ADC data register, and then some of the global variables we will see in the debug window. Okay, so now, so already this code, okay, let me compile this code. You can see here, so 0 errors and 0 warnings. Now let us go to debug window here, go to debug, you can select and enter into debug window. Yes, I'm able to enter into debug window. Okay, so guys, currently whatever you are seeing, this is called a debug window, where you will be able to see the various parameters. You can see here, so this is your live expression. The live expression is nothing but the global variable what you have declared. Here you can see this is one of the global variable, and this is one of the global variable, and this is also one of the global variable, and all these three I have mapped to the live expression section. Okay, how to do that I'll explain in the next video. So just you need to right click and you can give the name, that's it. Okay, so all global variables I have declared and I have taken it to a live expression. So if the registers are not available in the debug perspective, you can go to Windows here, and you can go to the show view here. There are two important register sets available. One is called core registers. The register whatever you're seeing, this is called core register, nothing but ARM core registers. So this is ARM core registers, and SFRs nothing but your peripheral register. The SFRs are nothing but the peripheral registers. Okay, the peripheral registers are nothing but ADC, GPIO, DAC, UART, SP, and so on. So you should know the differences here. When we say register, it is a core register, and when we say SFRs, nothing but peripheral registers. I will open both and I will show you how they looks like. Okay, so go here and open the registers. Yeah, here you can see when I say register, so this is going to open our core registers, nothing but our R0 or our ARM Cortex registers R0, and you can see here up to link register and so on. Right, this is the first important thing you should know. And second important thing is I need to open my SFRs. Here you can see this is your SFR. Okay, so these SFRs are nothing but your special function registers. Okay, so now if you look into the code, I will go line by line execution. So this is your code view. So I have three parts here. One is the code view. This is called my code view. Okay, our code window. and this is your special function registers, nothing but our your peripheral registers. And just I'll write it down here. This is my code and this is my registers, or you can say peripheral registers, and this is my variables. Or okay, so I have three windows. I kept it open. Now we will see one by one how each line is going to execute and how we can see the output in the peripheral registers and in the variables as well. So one by one we'll see now. So I'll keep it. So I want to monitor this. Let us assume I want to monitor line number 26. What line number 26 says? Line number 26 says I need to enable the, you can see the comment of whatever I have written, enable clock to the port A, line number 26. So now how it works, now let us see here. This is my RCC. You can see these are all the different names. You can see ADC, ADC1, CRC, debug. Every register structure they have defined with the name. So now I'm talking about RCC here. You need to open RCC, expand the RCC here. You can see this is my RCC, and under this RCC I need to open AHB1 ENR. Okay, so you can see here there's somewhere you will get. Yeah, here you can see this is my AHB1 ENR, right? So now, yeah, so guys, now you can see here I have run the code till here. That means, so this code got executed right now. This code executed, that is nothing but RCC AHB1 ENR. So now what I did here, I have enabled the clock to the GPIO 1 or GPIO 8, right? So that is like first instruction I have executed. Now I will execute the next instruction, and you can observe here the GPIO A got 1 in the RCC, right? So it's similar to that. Now I will execute till here, the line number till line number 30, execute up to line number 30. So now what happened? Okay, now I need to check the APB2. I'll just minimize this one. I will open APB2. You can see this is my APB2. So I'll expand this APB2 and observe what is happened right now. So I executed this statement RCC APB2 ENR. So now RPB, yeah, here you can see, right? So now I got executed RCC APB2 ENR. That means the clock is enabled for ADC, this one, right? Now I will execute this statement line number 30. So that means I need to go to the next line, go here and line execute. So what is the register name? ADC1 common CCR2. Now I need to go for this register here. So it will be available here. You can see this is my ADC common, and here there is something called ADC CCR, right? So now what it means, actually the statement, if you see here, enable the temperature sensor which is available inside the microcontroller. Okay, so that is the meaning here, and the same thing is happened here. So this statement executed right now, and this you can see here, right? It got executed and it became 1. Next statement I'll go. So what is the next statement? I need to enable the channel number. I'll execute till here. ADC1 SQR3. Now go to ADC1 here and find out your SQR3. This is my SQR3, and here you can see. So this is my SQR3. This is my register SQR3, and I'm just loading a 16 here, indicating that, okay, you're seeing this is displaying in hexadecimal. This I'm displaying in this I'm doing in a decimal. Okay, so both are same. So now SQR also loaded. Okay, next statement I will show you. In ADC I'm going to use a CR2. I will execute till here. So now I need to check with the ADCR2. That means this register I need to check. Let me check what is going to happen with that register. So this is my ADC CR2, and you can see here this is my ADC CR2, and here you can see the right ADC1 on, right, ADC on, correct. Okay, now next is, so now what I will do, I will run up to this statement. This statement I'll run. So line number 43, just go here, run to the line number 3rd. So now I need to check the status register here, SR, ADC1 SR. So now you can just see where it is. This is your ADC. Yeah, here you can see this is my status register, and here I need to check end of connection, whether the end of connection bit is set or not. So try to understand here. So I'm talking about end of conversion register. Okay, so here line number 41. Okay, line number 41, and I'm checking EOC bit here. So that means at this moment the analog to digital conversion already completed. Okay, so that is reflected in end of conversion bit, EOC bit, right? So now this is also, we have debugged, it is working fine. Now what I will do, I will read this digital data which is available in the ADC data register, that I will read it now. So I'll run till here. This time I need to read with the data register, so we will check where it is available. Yeah, here you can see this is our data register. Okay, so now what we did, we have executed this instruction and loaded with, yeah, here you can see, so data, whatever we got the data, that is loaded to the digital value, right? So you can see here live expression. So this value currently, whatever you are seeing, this is your decimal value and this is your hexadecimal value, right? Now after this I will go for one more step, execution. Till here I'll go. Yeah, now you can see the actual temperature also got updated here in the live expression, right? So in this way we can debug the code using debugger, provided your microcontroller should have a debugger inside, and also you should have a debugger circuit. So I'm using here STM32 microcontroller, which is already available in the STM32 nuclear board. With the help of the debugger circuit, I can read the data from the register in a real time. Okay, so this is called debugging process for your microcontrollers. You can understand the behavior of microcontroller in the line by line as well. So this is a very important, and every microcontroller engineer or every embedded engineer should know how to debug the code line by line and understand the behavior of your microcontroller. So I hope this video is an informative video. If you feel this video is an informative video, please click on bell icon, please click on like button, share this videos to your friends and colleagues, and subscribe to my YouTube channel and click on bell icon. Thank you for watching.